Are we charging plane batteries?
Yeah.
Yeah. Isn't that cool?
Yeah.
Yeah. This way, when we go out in the summertime, we can keep charging batteries and fly as much as we want, right?
Yep.
Yup. Okay, this video is going to be a little bit different. This is a bunch of wiring, therefore a wiring project. So probably a little more advanced. It's not a how-to. What it is a great idea. At the very end of this video, I put some discussion on how this thing works, the advanced version. But the simple version that you see in the beginning, anyone can build. So for you, if you want to build something like this, you can pick easy, medium, or hard. So this is the first version I built. It was very simple. It was a deep cycle battery, power port, which gave me a cigarette lighter adapter to an inverter, and I plugged my RC charger into the inverter. Very simple. The last thing on here is a little trickle charger for the battery. This is the second version, which really just amended version 1 because I forgot to put a power shutoff. So I added this little switch box with a little red light so I knew DC power was on. I also added a fuse on the output of the battery because running batteries without a fuse is dangerous. So every time I added to this box, I would do this operation of grinding off the tips of the screws sticking out the wood. I got tired of trying to find short screws, so I just said, screw it, shot screws right through the edges, and then just ground them off. This worked out a lot better because I could sink a screw all the way through the 3/4 inch plywood. So the assembly video I have for you is really the version 3 upgrades. That really was the hard part anyways, so that's kind of what I'm showing. I cut out most of the footage of me making the little pigtails and doing the small wiring details and crimping and shrink wrapping, because really if you're going to build one of these, yours is going to be different. So I spent some time here showing how I got the relay in here. The reason I put it in this box is that I was trying to segregate all the AC power, which is a lot more dangerous, in this double gang square box. The DC power is in the single gang, the littler one, keeping the two separate. To me, it just made sense this way. In a perfect world, I probably should have used a triple gang and put it all together, but because this box evolved a couple times, this is just kind of how it came out. So this power cord is actually a cord from an old shop light that I cut off. I always cut my cords and save them. Here I'm using a multimeter to figure out which of the two prongs is the hot lead and marking it. I know the middle wire on this cord is ground. That's how they're all built. Usually it's green too, but the other two are the same color, so you just have to figure out which is which. This is a trick I learned at my first job from the technicians who used to build electronic boxes. You take the number of wires you want together, put one in a vise, put the other end in the chuck of a drill, and then turn the drill on, and it will slowly wind the wires up really nice. If you notice, I'm using crimp connectors everywhere. It just makes it easier. You'll also notice that for every crimp connection, I'm putting on shrink wrap. I just don't want any problems with anything shorting out, and this is the easiest way I know how. So I built this entire double gang as basically a sub-assembly on a bench, which is easier to handle. Then once I got it done, you can see here I'm just mounting it in and pushing everything together. Red cord on the left is the DC in from the battery, and then DC back out to the single gang switch box. To provide DC power into the charger, I went to the hobby shop and just bought one of these weird connectors, whatever they're called, whacked the leads off, and then just added my own and extended them. This is DC power out of the single gang box into the RC car charger. This project was my first foray into using this HVAC ducting metal band stuff. It's amazing, it's strong, it's easy to work with, very flexible. The only problem with it is the edges can be extremely sharp if your hand slides on it. Here I'm wrapping the metal in electrical tape because I had just gotten cut really bad on my hand. So lesson learned there, wrap all this stuff in some kind of protective layer before you actually screw it down. So here I'm testing the relay safety interlock. DC power on, RC charger on. You can see it's really running on DC power by removing the AC power. Turn AC power on, the relay shuts DC off. Then I plug AC power in and you can see the charger come back up. I turn DC power off, turn AC power off, and again, you can see the same sequence repeated. Perfect.
I can't see it when it's in the white.
You see it?
Yeah.
So, if you watched one of my previous videos where I showed the tractor wiring schematic, if you like that, you're gonna love this. Okay, so the object of the exercise here is to charge an RC car battery, or RC plane, or whatever. I need a way to charge batteries without wall power. I'm sure I could just hook an inverter to a car and do it that way, but it's just not practical to me to do that with the ignition on. I don't want to do it that way. I want to be able to walk out in the middle of a field and do whatever I want, and I want the freedom. Since I had 99% of these parts on hand, I just did it this way. Okay, so here we go. This is how it works. Here's the RC battery charger right here. It can accept wall power, 120 volts AC, or it can accept DC power, 12 volt DC. So let's talk about case one, running this box under wall power. What can I do with it? Here's my white cable plug that you saw plugged into a wall. Here's that square double gang box that I showed with the outlet and the switch. So let's talk about how that box works. There's a switch that turns AC power on or off inside this box. That's what this switch does. All it does was turn power on to that single outlet right there. When AC power is on, two things receive AC power: the RC car charger and the really fancy AGM battery charger I bought. Therefore, I can charge RC batteries when this system's under wall power. The advantage to that is that simultaneously I can recharge the deep cycle AGM battery that I have in there, which has quite a bit of power. That fancy charger comes with an inline 1 amp fuse because it's basically a trickle charger. When this outlet has power, the neutral and the hot are also connected to a relay. So this is a 120 volt coil relay. So let's talk about what happens. When that relay receives power, it pulls these two contacts this way, connecting them to here absolutely nothing. The point of that is to disconnect the battery from all the 12 volt stuff in the box so that I'm not simultaneously powering the RC charger from wall power and DC power, but more importantly, that the fancy charger isn't charging the battery that's being discharged into a 12 volt load of some sort. When you flip that switch off or just unplug the cable from the wall, then the DC system is enabled. So this position here is what's called normally closed. Relays have two positions, normally open and normally closed. So I've used the normally closed connection so that under no power, it's always closed. The path is closed. So let's talk about the DC side now. Case 2 is under DC power, i.e. no wall power present, whether the switch is off or the plug's just unplugged and we're sitting in a field. So for that case, there's no power here to the RC charger. There's no power here to the battery charger. So we're really just looking at the battery and this stuff over here. So let's talk about that. So this is an AGM battery. It's actually a deep cycle battery, so you can discharge it for a very long time without damaging it. I originally purchased this battery and the fancy charger for my son's toy tractor, and Eva had a toy little quad. I got them with no batteries, and James didn't even have a hood, so I built him a hood. I bought 2 of these batteries and 2 chargers so that they would have power, because the ones that the company that made them, they were so expensive, it was cheaper to just buy an $80 battery and a $30 charger than to go buy the cheap junky one and the junky charger that the original company that made these vehicles sold. I'm not kidding. These things would run for 5 hours continuously without running out of battery power. I think they only ran them out once, and that was with like 6 kids all taking turns on it. So I don't know how much current this RC charger really draws. I took a guess that it was under 20 amps. So this relay, each of these connections is rated for 10 amps, and I had a feeling that that wasn't going to be enough. So what I did is, the power coming out of the battery is split between 2 sets of contacts. So if that's a 10 amp, that's a 10 amp, that means I can do 20 across the two, because I know the current will balance equally because there's a little bit of resistance in each of these, so it should pretty much come out. So I've got a 20 amp fuse. So you'll notice this fuse isn't inside a box. It's actually sticking out of the side of one of these 2 boxes, I forget. It doesn't really matter where it is, as long as it's between the battery and the load. So what's in that single gang box? A lot of the iteration that I did between version 1, 2, and 3 was in this box. So it's pretty much jammed with stuff. If there's power up to this point, because we're not running on wall power, the first thing that happens is it comes into a switch. You'll notice I just used a standard wall switch. Good enough for me. So I can turn the DC on and off at will. That way, if I'm traveling and I don't want this thing turned on during transit, I can just turn the DC power off. That was actually an addition in iteration 2. Iteration 2, I believe, also added this red LED because I couldn't tell if power was on or not. I ran DC voltage out to a power port, like one of those cigarette lighter deals, which I have running to an inverter, because I wanted to be able to use this rig for more than just RC car charging. I wanted to be able to use it as basically a portable power brick for whatever I could possibly want to do with it. The other thing that's on that double receptacle is 2 USB chargers. So this is really that black thing in the picture. I have one of these on the dash of my van. I had a couple extras, so I just nabbed it and threw it on this box. And ultimately, the object of the exercise is to get 12 volt DC power all the way to that RC car charger. I hope that makes a little bit of sense. If you wanted to, like I did in version 1, all I had was the battery to the power port and USB, And then the RC car charger was running off the inverter. That was version 1. Version 2 added the switch and the LED. Still same setup. And then I decided to get fancy because I was tired of moving the RC charger from inside the box to outside, like unplugging here and plugging to the wall and back and forth. It seemed silly. So version 3 is where I got really fancy and added this double gang with all this stuff I discussed in the relay. Everything in this picture I had on hand with the exception of the fuse holder and this relay and the red LED. Everything else I had on hand. So I'm in for a total cost of $10 of my own hard-earned money. I also tried to show a few cable lengths on here to give you an idea of what these runs were. This is the 4-foot cable the charger came with. This is about a 6-foot cable that the charger came with. And then the cables from this gang box to that gang box were around 2 foot. I just made them too long, ran them to the boxes, and then just trimmed them to fit. So I hope this makes sense, and maybe you'll have fun building your own. You can do a fancy one like this, or you can just do it battery to inverter to that. That's the poor man's setup. Anyways, thank you for watching, and have a nice day.